The sky has always felt quiet, calm, predictable. For centuries we believed we understood its rhythm. Planets followed their paths. Comets arrived from known directions. Everything moved within invisible lanes, shaped by gravity and time. Then one night, something didn't. It didn't announce itself with fire or noise. It didn't streak across the sky for anyone to wish upon. It arrived silently, slipping into our instruments like it didn't care if we noticed at all. The first detection came from a routine scan. Just another automated sweep of the heavens. Thousands of points of light, blinking in and out of existence. Most of them meaningless. Most of them ignored. But one data point refused to behave. At first glance, it looked ordinary, a faint object. Cold, distant, moving slowly against the black. The system flagged it as unknown. That happens more often than people think. Space is full of surprises. New asteroids, lost debris, old comets returning for another pass. So the object was given a name, a simple label, nothing dramatic. 3IATLAS, just letters and numbers, nothing that hinted at what was coming. But when scientists plotted its path, the room went quiet because 3I/Atlas wasn't following the rules. Most objects in our solar system move along the same flat plane, a cosmic disk called the ecliptic. It's the result of how the sun and planets were born. A spinning cloud that flattened over billions of years. Everything agrees to that order. Planets, asteroids, even long-period comets. Everything except this. 3I/Atlas was coming in at a steep angle, not drifting gently into the system, not looping around the sun like a visitor returning home. It was cutting through, like a needle through fabric, like it didn't belong to the same story. Astronomers checked the data again and again. Maybe the orbit was wrong. Maybe the software glitched. Maybe a decimal was off. But each recalculation brought the same result. The angle stayed wrong. The direction stayed strange. And the speed was unsettling. It wasn't just fast. It was too fast. Fast enough to suggest this object wasn't bound to our sun at all. Fast enough to hint at something far more rare. An interstellar origin. Only twice before had humanity confirmed objects like this. Visitors from beyond our solar system, ancient travelers from other stars, and now possibly a third. But even compared to those, 3I/Atlas felt different. As observatories around the world turned their attention toward it, a clearer picture began to form, or at least a clearer mystery. The object showed no visible tail, no dramatic plume of gas, no obvious signs of ice burning away in sunlight. For something approaching the inner solar system, it was strangely quiet. Its brightness stayed low. Its profile stayed clean. Too clean. Still, no one panicked. Science doesn't leap to conclusions. It walks. Slowly, carefully. So researchers did what they always do. They gathered more data. They watched its motion frame by frame. They measured its position against distant stars. They traced its path backward, trying to find where it came from. And that's when the problem deepened. The trajectory didn't point to any nearby star system. Not cleanly, not convincingly. It was as if its past had been erased or scattered, as if the object wasn't launched from somewhere, but passed through, Through regions of space we don't normally see objects survive. That alone wasn't impossible, just unlikely. But then came the timing. 3I/Atlas was discovered late. Later than expected for an object of its size and path, which raised an uncomfortable thought. How long had it already been there, moving quietly, unnoticed, crossing the dark without a sound? Had it only just arrived? Or had it been watching us, long before we knew how to watch back? At this stage, the questions stayed technical, safe, contained within academic language. Uncertain origin, non-standard inclination, further observation required. But beneath those words, something else was growing. A feeling, the kind scientists rarely talk about, but always recognize. The feeling that something doesn't fit, that the story you expect space to tell is about to change. Late nights turned into early mornings. Screens glowed in dark control rooms. Coffee cups stacked beside keyboards. Because once you see a pattern break, you can't unsee it. 3I/Atlas wasn't just another object. It was a question written in motion, in angle, in speed. A question aimed directly at our understanding of where things come from and how they move through the universe. Outside the observatories, the world went on as usual. Cities slept. Lights flickered. People looked up at the sky without knowing anything had changed. But somewhere above them, something unfamiliar was passing through their cosmic neighborhood. Not glowing, not calling attention to itself, just moving, waiting. And with each new data point, one thought became harder to ignore. If 3I/Atlas didn't come from where we think it did, if it didn't follow the paths everything else follows, then maybe the real discovery wasn't the object itself. Maybe it was the realization that our map of the sky has blind spots, and maybe something just slipped through one of them. As the object continued its quiet approach, scientists prepared for the next phase. Closer observation, better instruments, sharper measurements. Because soon 3I/Atlas would reveal more than just its path. Soon its light would begin to speak. And when it did, nothing about this discovery would feel ordinary again. At first, the object stayed quiet. Not silent, just distant. A faint point of light moving through black space, barely strong enough to stand out from the noise of the universe. For days, 3I/Atlas was just another dot on a screen. Another cold traveler drifting toward the sun. But then the data began to stack up. Night after night, telescopes tracked its brightness, not with human eyes, but with machines that measure light down to tiny fractions. This is how astronomers listen to space. They don't hear sound, they read light. Every object tells a story through brightness. As it spins, reflects sunlight, or releases gas, its glow changes. Those changes form a curve, a light curve, and most of the time, those curves are smooth. Gentle rises, soft falls, like waves. That's physics. That's nature. So when the first light curve of 3I/Atlas appeared, no one expected surprises. But when the graph finished rendering, the room went still. The curve wasn't smooth. It didn't rise slowly. It didn't fall naturally. Instead, it jumped. Sharp increases, sudden drops, flat lines. Then another jump. Like stairs, astronomers stared at the screen, waiting for the explanation to appear on its own. It didn't. They zoomed in. They smoothed the data. They removed background noise. Still the same. Step, pause, step, pause. That wasn't how rotating rocks behaved. That wasn't how ice reflected sunlight. That wasn't how comets breathed as they warmed. This wasn't a curve, it was a pattern. Someone quietly suggested an error. A faulty sensor, a calibration problem, a software glitch. That suggestion brought relief. Because errors are comforting. Errors mean the universe still makes sense. So they checked everything. They compared instruments across different observatories, different countries, different systems. And that's when the relief faded, because the pattern was there too. Different telescopes, same steps, different nights, same rhythm. The brightness of 3I/Atlas wasn't changing randomly. It wasn't flickering like noise. It was switching. On, off, on. Not like a star, not like a comet. More like a signal. No one said that out loud at first. Because that word carries weight. History. Fear. So they chose safer language. Unusual reflectivity. Non-standard rotation. Anomalous light behavior. Words that sound calm, even when the data isn't. But behind closed doors, the questions grew louder. What could cause such clean transitions? If the object were tumbling, the changes would blur. If it were venting gas, the brightness would smear. If it were breaking apart, the curve would be chaotic. But this wasn't chaos. This was control. The steps were too precise, the timing too consistent. The object would hold one brightness level, then change suddenly, as if something had been turned. Astronomers began comparing the timing of the jumps. Minutes, hours. The spacing wasn't perfectly regular, but it wasn't random either. It felt intentional. That's when the word patterns started appearing in internal notes. Pattern is dangerous, because once you see a pattern, your mind starts asking why. And science is careful with why. So they searched for natural explanations. Maybe it was a strange shape. A flat surface reflecting sunlight directly toward Earth. A sharp edge rotating in and out of view. That idea held, briefly, until they modeled it. To create steps that sharp, the object would need geometry unlike anything seen before. Not rounded, not jagged, but clean. Engineered clean. Another theory followed. Maybe it was tumbling wildly, flipping between orientations. But tumbling creates noise. This was too stable, too deliberate. The light curve didn't look alive. It looked programmed. At this point, no one was talking about aliens. Not seriously. But they were talking about artificiality. Quietly, carefully, as a question, not a claim. Could an object passively produce a signal-like pattern without meaning to? The answer wasn't comforting, because the more they tested, the more the curve refused to behave. And then something else happened. As 3I/Atlas moved closer, the steps became clearer, stronger. The signal-to-noise ratio improved, and with it, the certainty. This wasn't a mistake. This was real. The brightness levels weren't random values. They clustered, specific levels, repeated, as if the object had states, modes, like it could be on or off, or something in between. Some researchers tried to slow the data playback, frame by frame, watching the light change as the object rotated. But it didn't feel like rotation anymore. It felt like response, as if 3I/Atlas wasn't just reflecting sunlight, but doing something with it. And then came the most unsettling thought of all. What if the light curve wasn't caused by rotation at all? What if the object wasn't spinning to create brightness changes? What if it was choosing when to reflect? That idea crossed a line, because choice implies agency, and agency implies purpose. So again they pulled back. They reminded themselves of the rules. Extraordinary claims require extraordinary evidence. This wasn't evidence. Not yet. But it was enough to change the tone. Emails became longer. Meetings became quieter. The data was shared with more teams. Independent verification. Because if this was wrong, it had to be proven wrong. But if it was right, then the sky was doing something it had never done before. Outside the labs, no one noticed. The object was still invisible to the naked eye, still just a number in a catalogue. 3I/Atlas. But inside the charts and graphs, a strange realization settled in. Light is the oldest messenger in the universe. Everything we know about space comes from it. Stars tell their age with it. Galaxies tell their motion with it. And now, this object was telling something too. Not loudly, not clearly, but enough to make scientists pause. Enough to make them lean back in their chairs and stare at the screen. Because the universe wasn't whispering anymore. It was tapping. Gently. Deliberately. And the question was no longer, what is this object made of? The question had shifted. Is this just an anomaly? Or are we looking at the first hint of a signal that was never meant to be ignored? As 3I/Atlas continued its approach, the light curve kept stepping, waiting. And with every rise and fall, one quiet fear grew stronger. What if this wasn't noise at all? What if this was the object's way of saying, it was here? And if so, who was it meant for? At first, they hoped it would fade, that the strange steps in the light curve would soften with time. That distance, angle, or error would explain everything away. Because patterns have a way of disappearing once you look closer. But this one didn't. As 3I/Atlas moved deeper into observation range, more telescopes joined in. Not because of fear, because of curiosity. Whenever something strange appears in the sky, the world listens together. Chile, Hawaii, Spain, Australia. Different instruments. Different teams. Different skies, all watching the same object. And slowly, something else emerged. Not just steps, not just brightness changes, a rhythm. When scientists lined up the data in time, they noticed something unsettling. The changes weren't only sharp, they were timed. The brightness would rise, hold, then fall, again and again, like a heartbeat. At first, it was easy to ignore. Space is full of cycles, rotations, orbits, waves, so no one reacted right away. But then someone did something simple. They overlaid the data from two observatories, thousands of miles apart. Different weather, different equipment. And the pulses lined up perfectly. The same rise, the same pause, the same drop. To the second. The room went quiet, because noise doesn't do that. Noise argues with itself. Noise stumbles. Noise never agrees across continents. But this agreed. Someone whispered the word, synchronization. Another whispered, impossible. They checked the clocks, timestamps, calibration logs. Maybe the systems were accidentally linked. Maybe there was a shared reference error. So they compared with a third observatory. Same result. A fourth. Same pulse. At that moment, coincidence stopped being a safe answer. The universe allows randomness, but it rarely allows perfection. The pulse wasn't perfectly regular, like a metronome. That would have been easier to explain. Instead, it drifted slightly. A few seconds longer here, a few seconds shorter there. Enough variation to look natural, but not enough to be random. It felt deliberate, like something adjusting itself. The brightness changes weren't reacting to Earth. They weren't reacting to weather or angle. They were happening on their own schedule, independent of us. That realization changed everything. Because now, the light curve wasn't just wrong. It was active. Scientists began calling it a temporal pattern. A polite phrase, but in plain terms, the object was pulsing, not in response to sunlight, not because of rotation, but because something was happening on the object itself. They tried to break the pattern. They filtered the data in new ways, removed suspected interference, changed sampling rates. The pulse survived every test. Then came the most uncomfortable step. Someone asked a question no one wanted to answer. What if this isn't a byproduct? What if this is the main event? If the object wasn't passively reflecting light? If it wasn't simply tumbling through space? Then what was causing the pulse? Theories flooded in. Maybe internal heating cycles. Maybe exotic chemistry reacting to solar radiation. Maybe stress fractures, opening and closing. Each theory sounded reasonable. Until the math was done, none of them fit the timing. None could explain why the pulse appeared before perihelion, when solar energy was still weak. None could explain the consistency across angles and distances, and none could explain why the pulse sharpened as observation improved. Instead of blurring, it clarified, like it wanted to be seen. Late one night, a young researcher plotted the brightness changes as binary states. High, low, on, off. The result wasn't a message, not words, not numbers, but it wasn't random either. It was structured. And structure is dangerous, because structure implies rules. Rules imply intention, and intention changes the conversation completely. At this point, no one was claiming intelligence, but the idea of mechanism entered the room, something cycling, something operating. Not alive, but not inert either, like a machine running without caring who noticed. And then another layer appeared. The pulse frequency wasn't constant over weeks. It drifted, slowly, as if adapting, as if responding to conditions in space. Temperature, radiation, distance. That behavior matched one thing very well. Systems designed to survive. Some researchers began asking questions they had never asked before. If this is a system, who built it? If it's ancient, why is it still working? If it's not meant to communicate, why does it produce such a clean signal? The word signal was still avoided in public discussions, but privately, it was everywhere. Because the pulse looked less like geology and more like output, like a process completing cycles. And the most unsettling part, the pulse didn't weaken as the object approached the sun. It strengthened, as if powered, as if waking up. That thought sent chills through rooms full of people trained not to feel them. because comets fall apart as they heat up, asteroids crack. Machines, however, often perform better with energy. No one said that out loud, but everyone felt it. Emails became cautious. Papers used passive language. An observed periodicity, a persistent anomaly. But behind those words, a quiet fear grew. If this was natural, it was unlike anything ever recorded. And if it wasn't, then humanity was witnessing something entirely new. Something moving through our solar system with its own internal rhythm, its own clock, and its own reasons. The pulse kept coming, not faster, not louder, just steady, patient, unconcerned with our confusion. As if it had been doing this long before humans built telescopes, and would continue long after we stopped watching. At this stage, the data alone was enough to change minds. Skeptics stopped laughing. Believers stopped speculating. Everyone started listening, because whether accidental or intentional, something out there was keeping time. Perfect time. And that raised a question that felt heavier than all the others combined. If no one on Earth set the clock, then who did? As 3IATLAS moved closer, carrying its pulse through the dark, one truth became impossible to ignore. Noise had become structure. Structure had become rhythm. And rhythm is how systems announce themselves. The universe wasn't just flickering anymore. It was beating. And the next question wasn't, what is causing the pulse? The next question was far more unsettling. What happens? When the pulse changes, space is supposed to be honest, cold, brutal, unforgiving. Out there, nothing hides heat for long. Energy bleeds away. Objects freeze. That's the rule. So when scientists turned to thermal data, they expected clarity, numbers that would calm the storm, proof that 3I/Atlas was just another strange rock doing strange things. Instead, the numbers made everything worse. Infrared instruments began tracking the object's temperature as it moved closer to the sun. This wasn't new science. Astronomers do this all the time. Heat tells you what an object is made of, how it reacts, how it survives. Comets warm up slowly. Asteroids heat unevenly. Nothing surprises you if it's natural. But 3I/Atlas didn't warm the way it should have. At first, the readings looked normal, cold, flat. Then a jump, not gradual, not smooth. A sudden rise. Then it held. Hours passed. The temperature stayed steady. Then, just as suddenly, it dropped. No shadow crossed it. No rotation explained it. No jet of gas burst outward. The heat changed. Without a cause, scientists assumed a mistake. They always do. Sensors drift, instruments glitch. Space is hard to measure, so they recalibrated. Compared data across wavelengths. Double-checked pointing accuracy. The result stayed the same. Sharp thermal shifts. Controlled plateaus. Clean transitions. Heat behaving like a switch. That shouldn't happen. In space, temperature changes smear over time. Energy doesn't turn on and off. It leaks. It fades. But this didn't fade. It stopped. And then it started again. Someone quietly overlaid the thermal data with the light curve. The alignment was chilling. When the brightness stepped up, the temperature rose. When the pulse dropped, the heat fell. Not always instantly, but close enough to notice. Close enough to feel wrong. This wasn't random heating from the sun. This wasn't friction. This wasn't chemistry. This was regulation. The object wasn't just reacting to energy. It was managing it. That word, managing, made people uncomfortable. Because management implies control, and control implies design. Theories rushed in, trying to stay safe. Maybe it was an unusual mix of materials, exotic ice, metal-rich rock. But every simulation failed. To hold heat that steadily, the material would need insulation beyond anything known in natural objects. Not porous ice, not dust, not stone, insulation-like. Layers, purpose-built layers. Another theory suggested internal reactions, some hidden chemical process turning on and off. But chemistry doesn't follow clean schedules. It doesn't pause politely. It doesn't sync with light pulses. This did. The more they watched, the clearer it became. The thermal pattern wasn't chaotic. It was efficient. The object absorbed energy, stored it, released it, as if optimizing survival, as if protecting something inside. That thought changed the tone of the room. Because now the object wasn't just pulsing light, it was controlling heat. Two systems, working together, in deep space, at temperatures that kill complexity. Someone asked a question that stopped the conversation cold. What if this thing isn't cold? Not warm like a comet, not hot like a star, but internally stable, operating. That idea sounded absurd, until the math supported it. Internal temperature estimates suggested something unexpected. Not freezing, not boiling, but regulated within a narrow band. The kind of band systems need to function. The kind of band machines prefer. At this point, no one was smiling. This wasn't excitement anymore. It was unease. Because space does not protect working systems. Radiation destroys them. Time erodes them. Cold shuts them down. Unless they were built not to fail. Unless they were never meant to stop. The thermal data also revealed something else. As 3I/Atlas moved closer to the sun, the object didn't simply heat up. It adapted. The temperature spikes became shorter, more controlled, as if compensating for increased solar energy, like a thermostat adjusting. That behavior terrified the models, because nothing natural adapts like that. Nature reacts. Machines regulate. The word machine still wasn't spoken publicly, but it hovered over every discussion. Uninvited, heavy. Because if this was a machine, then it had been drifting between stars for who knows how long. Surviving radiation, surviving impacts, surviving time itself. Still working, still pulsing, still managing its heat. Someone finally asked the question no one wanted to answer. If it's managing energy, what is it using that energy for? There was no answer. No moving parts visible. No exhaust, no obvious output. Just light, heat, pulse, as if the function was internal. As if the purpose wasn't for us. That idea made people uneasy in a way data never had before. Because now, the object wasn't just strange. It was indifferent. Indifferent to discovery. Indifferent to observation. It wasn't performing. It was existing. And existing very well. The more scientists tried to fit it into known comet behavior, the worse the fit became. Comets shed mass. 3I/Atlas didn't. Comets heat unevenly. This didn't. Comets weaken as they approach the sun. This seemed to strengthen. The thermal stability suggested durability, longevity, intentional design to endure long journeys through hostile space. That realization shifted the fear. This wasn't a threat. At least, not yet. It was something else. A reminder that intelligence, if it exists elsewhere, might not arrive as a message. It might arrive as a system. Quiet, efficient, uninterested in us, just passing through. As days passed, thermal readings kept coming, and every new data point whispered the same thing. This object knew how to take care of itself. That thought lingered long after the screens dimmed, because cold space doesn't hide working machines, not easily. And yet, here one was, managing its energy, holding its temperature, pulsing with quiet purpose. As 3I/Atlas continued its approach, one question refused to leave. If something can survive the dark between stars, what else can it do? And more importantly, what happens when it reaches the point where survival is no longer the only goal? By now, scientists weren't looking for comfort anymore. They were looking for honesty. When something refuses to behave like nature, you stop asking why it's strange and start asking what it really is. So they turned to spectra, because light doesn't lie. Every surface tells its story by how it reflects light. Ice absorbs certain colors, rock scatters others, dust leaves fingerprints you can't hide. Spectral scans are like fingerprints of matter. You shine light, and the object answers with chemistry. At least, that's how it's supposed to work. When the first spectral data from 3I/Atlas came in, the results looked clean. Too clean. No messy absorption lines, no dusty signatures, no complex blends of ice, rock, and debris. Just sharp reflectivity. Defined, controlled, like light bouncing off something smooth. Astronomers blinked and checked the scale. Maybe the resolution was too low. Maybe the noise was hiding the detail. So they zoomed in, and the problem became worse. The surface wasn't scattering light the way broken material does. It wasn't diffusing. It wasn't bleeding energy. It was reflecting, efficiently, as if designed to do exactly that. Most comets are dirty snowballs, covered in dust, scarred by impacts. Their spectra are chaotic, because they're chaotic objects. 3I/Atlas wasn't chaotic. It behaved like it had a finish, a surface that didn't erode easily, a surface that stayed consistent as angles changed. As the object rotated, or whatever motion it had, the reflectivity stayed stable. No random flares, no uneven patches. Just consistent response. That consistency set off alarms, because in space, nothing stays clean for long. Micrometeoroids sandblast surfaces. Radiation scars them. Time roughens everything. Unless it's protected, unless it's built to resist. Someone quietly overlaid reflectivity data with thermal patterns. Again, alignment. The reflective surface wasn't just bouncing light. It was controlling heat intake. High reflectivity during intense solar exposure. Lower reflectivity during pulse transitions. Like a surface designed to manage energy flow. That's not geology. That's engineering. The word wasn't spoken aloud, but it didn't need to be. The data said it for them. Materials scientists were brought in. People who study coatings, composites, layered structures. They looked at the spectra and frowned. Natural materials don't do this, they said. Not without impurities, not without decay. This surface behaved like a composite, layered, purposeful, built to survive extremes. And the strangest part? There was almost no dust, no trailing particles, no debris cloud, which meant the surface wasn't shedding material. It wasn't aging the way comets age. It wasn't dying. It was enduring. As days passed, something else became clear. The reflectivity wasn't uniform, but the variation wasn't random either. It changed in segments, sections, zones, as if different parts of the surface served different roles. Some reflected more, some absorbed slightly more, all within tight limits, like panels. That thought made people uncomfortable, because panels imply construction. Construction implies intent. Intent implies a maker. By this point, even skeptics stopped arguing for simple explanations, not because they believed in something extraordinary, but because ordinary explanations had run out. You can stretch physics only so far. Eventually, it snaps. Emails between teams became cautious, measured. No one wanted to be the first to say the wrong thing. No one wanted to be the one history remembered for overreaching. But privately, one question dominated every discussion. If this is natural, why does it look finished? Nature doesn't finish things. It leaves rough edges. It leaves scars. This object looked maintained, as if time had passed but not affected it, as if it had been prepared for a long journey across interstellar space, across radiation fields that destroy electronics, across cold that freezes chemistry, still intact, still reflective, still precise. Someone finally asked the question everyone was thinking: what if we're not looking at a comet at all? That question changed the room, because once you remove the word comet, everything else starts to make sense. The pulse, the thermal control, the reflective surface, separate mysteries, now part of the same system. A shell, a body, a structure, not alive, but not accidental, something built to last. The idea wasn't that it was watching us, not yet. The idea was simpler and somehow more unsettling, that this object didn't care we were here. It wasn't signaling, it wasn't hiding. It was just passing through, the same way it had passed through countless systems before. And we happened to notice it. Reflectivity data continued to come in, and it never degraded. No dust plume, no erosion. Just the same clean response, again and again, as if time meant nothing to it. That realization left a heavy silence, because debris tells you where it's been. This object told nothing, no origin, no scars, no history, just function. And that raised a final, haunting thought. If this surface was engineered, if this object was designed, then its purpose wasn't to be seen, which means we may be observing nature's most uncomfortable possibility. Not life, not a message, but technology. Drifting, waiting. And as 3I/Atlas continued toward the inner solar system, reflecting sunlight with impossible precision, one question refused to leave. Are we witnessing a rare trick of physics, or the quiet proof that design can exist without intention toward us? Because if this was built, then somewhere, sometime, someone solved the problem of surviving the dark between stars. And that changes everything we thought we knew about the universe. Every object faces a breaking point. In space, that moment has a name: perihelion. It's the closest approach to the sun, the place where light burns hottest, where ice screams into gas, where weak structures fail. For comets, perihelion is a trial by fire. They crack. They vent. They shed pieces of themselves like ash. Some don't survive it at all. So as 3I/Atlas moved inward, scientists waited, not with excitement, with expectation. Because if this object was natural, perihelion would expose it. The sun doesn't lie. As days passed, solar radiation increased. Temperatures climbed fast. Models predicted stress. Everything pointed to chaos. Jets of gas should erupt. The light curve should shatter. The surface should flake and erode. That's what always happens. Except it didn't. The first perihelion data came in quietly. No explosion. No sudden brightening. No plume. Just stability. The object held its form. The light curve didn't collapse. It tightened. The steps became cleaner. The pulse became sharper, as if the extreme heat wasn't hurting it, as if it was helping. That moment sent a chill through the room, because nothing improves at perihelion unless it was designed to. Thermal readings showed intense solar energy flooding the surface, enough to destroy volatile materials, enough to rip weak structures apart. But 3I/Atlas didn't react like something under stress. It reacted like something under load, absorbing, redistributing, managing. The temperature rose, then flattened, right where it wanted to be, like a system protecting its limits. Some scientists compared the data to spacecraft heat shields. The resemblance was uncomfortable. Layered response, energy deflection, controlled absorption. These are solutions engineers design, not outcomes geology produces. As perihelion approached its peak, everyone expected something: a fracture, a deviation, a mistake. But the orbit stayed precise. The path didn't wobble. The object didn't shed mass. It passed its closest point to the sun and came out unchanged, better than unchanged, optimized. The reflectivity adjusted. The pulse frequency shifted slightly. The thermal cycle became more efficient. It was adapting in real time. That's when the word test began circulating quietly. Not our test. Its test. As if perihelion wasn't a danger, but a condition it was built to handle. That thought was deeply unsettling, because the sun is one of the most destructive environments in our system. If this object could endure that, what couldn't it endure? Some researchers revisited old assumptions. Maybe it wasn't ancient debris. Maybe it wasn't a relic. Maybe it was active, still functioning after an unknown journey, still responding to stress with precision, still following internal rules we didn't understand. The data showed no panic, no randomness, no breakdown, only control. And control changes everything. Because control suggests purpose beyond survival. It suggests design that anticipates extremes. A machine doesn't fear heat. It accounts for it. As the object began moving away from the sun, the patterns didn't fade. They persisted. As if perihelion had triggered something. Not damage, but calibration. Some scientists wondered if the object used solar energy as a resource. Charging, resetting, stabilizing. That idea was speculative, but the data didn't reject it. Once again, nature struggled to explain behavior that engineering made simple. And that was the most uncomfortable part. The simplest explanation was no longer natural. The sun had done its job. It had applied pressure, heat, radiation, everything that breaks weak things. And 3I/Atlas had passed through unscarred, still pulsing, still reflective. That survival forced a quiet conclusion. Whatever this object was, it wasn't fragile, it wasn't accidental, and it wasn't behaving like anything we had ever seen fall toward a star. As the distance from the sun slowly increased, one final detail stood out. The pulse, the one everyone had been watching. It didn't weaken, it didn't stop. It became calmer, as if the danger was over, as if the system had completed a phase. And that left scientists with a question that no equation could answer. If perihelion wasn't a threat, then what was it designed for? Because anything that can pass so close to a star and emerge improved wasn't built for comfort. It was built for endurance. And endurance implies long missions. Long purposes. Purposes that don't end in one solar system. As 3I/Atlas drifted away from the sun's grip, the fear shifted again. Not fear of destruction, but fear of scale. Because if this object survived perihelion without harm, then whatever made it understood stars, understood space, understood survival far better than we ever had. And that raised the next, heavier question. If this wasn't the moment it would break, then when would it reveal what it truly is? And more importantly, what happens next, now that the sun itself has failed to stop it? There is a moment in every investigation when the data stops being exciting and starts being dangerous. For 3I/Atlas, that moment arrived quietly. Not in public announcements, not in headlines, but in private documents, shared late at night between people who trusted each other. The word didn't appear in bold. It wasn't highlighted. It was slipped into sentences, carefully, artificial. At first, it looked harmless, almost academic. Artificial explanations cannot yet be ruled out. Non-natural structure remains a possibility. Careful language. Safe distance. But the meaning was clear. The data no longer supported accident. No one was claiming intelligence. No voices were saying aliens. That leap was still too far. But the idea of design, that was no longer off limits. Because everything about 3I/Atlas pointed in one direction. Control. Control of light. Control of heat. Control of survival. Natural objects react. They don't regulate. They don't stabilize under stress. They don't tighten their patterns when conditions worsen. Machines do. And that realization sat heavy in every room where the data was discussed. If this object was artificial, then it was doing exactly what it was built to do. The hardest part wasn't asking if it was a machine. The hardest part was asking why. Machines are built for reasons, for tasks, for goals. Even abandoned machines once had a purpose. So scientists began asking questions they had never trained for. Not equations, not simulations. Questions of intent. Was it a probe? A relic? A piece of infrastructure? Drifting without an owner? Could it be broken? Or worse, still working exactly as planned? The silence around those questions was thick, because none of the answers felt small. Some suggested it might be passive, a beacon, a marker. Something placed long ago, not to communicate, but to exist. Others proposed a shielded archive, a carrier, a device meant to survive stars and time itself. And then there was the most unsettling idea of all, that it had no interest in us whatsoever, that it wasn't visiting, it wasn't scouting, it wasn't observing, it was simply passing through, doing what it had always done. That thought was humbling in a way no discovery had ever been, because humanity has always believed that if something intelligent appeared, it would care, it would signal, it would speak. But 3IATLAS wasn't speaking, it was functioning. And function doesn't need an audience. As more internal reviews circulated, one conclusion kept appearing again and again. The object did not behave like debris. Debris doesn't optimize. Debris doesn't adapt. Debris doesn't survive perihelion untouched. And debris doesn't pulse with internal timing. At some point, denial became unscientific. The forbidden word stopped being shocking and started being practical. Artificial didn't mean alien life. It meant construction, structure, systems assembled with intention. That distinction mattered, because a machine doesn't have to think to change everything. A simple device, left behind, could still reshape our understanding of the universe. The more conservative voices urged restraint. Extraordinary claims, they reminded everyone. Unknown physics still exists. And they were right. Science must resist fear. But even those voices admitted something quietly. Whatever this was, it wasn't simple. And it wasn't explained by chance. At some point, someone asked a question that cut through all the theory. If this is a machine, why does it look so calm? There were no bursts, no erratic behavior, no signs of distress. The object wasn't panicking. It wasn't reacting to discovery. It wasn't reacting at all. It had passed perihelion, survived the sun, and continued on its path without deviation. That calm suggested confidence, as if it knew it would survive, as if survival was expected. That idea unsettled even the most composed scientists, because confidence usually comes from knowledge, and knowledge implies experience. How many stars had this object passed before ours? How many systems had tested it and failed to stop it? If it was a machine, it wasn't new, it was ancient, old beyond human timelines, still operational, still precise. That raised another quiet question. If it was built, was it alone, or was it part of something larger? No one wanted to think about that, so they didn't. Instead, focus returned to the data, to what could be proven. And what could be proven was this. The object did not behave randomly. It did not degrade. It did not fail. Every anomaly pointed toward intention, not intelligence, not communication, but purpose. And purpose without explanation is terrifying, because it leaves only one question standing. What does it do when it finishes passing through? Some speculated that perihelion marked the midpoint of a process. Others wondered if the pulse frequency would change again, or stop entirely. The idea that it might do nothing was somehow worse. A machine that simply passes through star systems, enduring, observing nothing, signaling nothing. That suggests a universe filled with remnants we never see. Technology older than memory, crossing space silently, not because it wants to be found, but because it doesn't care if it is. As the discussion grew heavier, one conclusion became unavoidable. Even if this object turned out to be natural, the possibility had already done its damage. We had crossed a line. For the first time, The idea of non-biological design beyond Earth was not science fiction. It was a reasonable hypothesis. And that changes how you look at the sky, because now every dark object, every quiet traveler, could be more than rock and ice. It could be history. As 3I/Atlas continued its steady path away from the sun, still pulsing, still stable, the machine question lingered like a shadow. Not loud, not dramatic, just present. If it is a machine, then someone, somewhere, once built something meant to last longer than civilizations. And if that's true, then the universe may be far less empty than we've always believed. Not full of voices, but full of things still working long after their makers are gone. And the most haunting part, if this machine has a purpose, it hasn't finished it yet. At first, the world didn't notice. That's how it always starts. Data moves faster than people. Charts update before emotions do, and discoveries live quietly, peace, until they don't. When fragments of the 3I/Atlas story began to reach the public, they arrived without drama, a few articles, a few cautious headlines. Unusual interstellar object. Scientists debate strange data. Nothing alarming. Most people scrolled past, because the sky has always been full of mysteries, and humanity has learned how to ignore them. But this one didn't stay contained. Because once a question escapes the scientific community, it doesn't stay scientific. It becomes human. Forums lit up. Videos appeared. Speculation spread faster than data ever could. Some laughed it off. Another clickbait space rock. Scientists seeing patterns where none exist. They wanted errors. They needed mistakes. Because mistakes mean the universe is still predictable. Others reacted differently. They didn't panic. They didn't shout. They just felt unsettled. A quiet shift in the chest. A feeling that something familiar had tilted slightly out of place. Because the story of 3I/Atlas wasn't loud. It wasn't dramatic. It was calm. And calm is scarier than chaos. As more details leaked about pulses, heat control, reflectivity, public perception fractured. Two realities formed. In one, this was just another scientific overreach, a misunderstanding, a statistical illusion dressed up as mystery. In the other, something had crossed a line, and we didn't know how to name it yet. The difference wasn't intelligence, it was trust. Trust in what the universe is allowed to be. For skeptics, reality is narrow. It follows rules. It behaves. For others, reality suddenly felt wider, too wide, because the idea wasn't that something was coming to Earth. The idea was worse. That something had already passed through, and we barely noticed. That idea hit people in strange ways. Some felt small. Others felt watched. Not because 3I/Atlas was observing us, but because we were no longer sure we understood what observation meant. Humans have always believed that looking gives us control. We see, we measure, we understand. But what if looking isn't enough? What if something can exist fully without caring that it's being seen? That thought shook people more than any threat ever could. Scientists felt it too. They just hid it better. Press conferences became careful. Language tightened. We cannot draw conclusions. Further study is needed. But behind the calm tone, something had changed. Because once the public starts asking questions, science feels pressure. Not to panic, but to reassure. and reassurance was suddenly hard. Because there was no satisfying answer, no clean explanation, just a growing list of things that didn't make sense. Some people demanded transparency. If it's artificial, say it. If it's nothing, prove it. Others demanded silence. Stop speculating. You're causing fear. But fear wasn't coming from the object. It was coming from the gap between certainty and doubt. For centuries, humanity has lived comfortably with the idea that space is empty, cold, and mostly dead. Beautiful ship, but harmless. 3IATLAS didn't threaten that belief with force. It threatened it with possibility. And possibility is dangerous, because it doesn't tell you what will happen. It tells you that more can happen. Late-night conversations changed. People stared at the sky longer, not expecting answers, but wondering what they'd missed before. If this object could slip through unnoticed for so long, what else had? The phrase, interstellar visitor, took on new meaning. Visitors usually come with purpose, with intention. This one came with none we could see, and that ambiguity fractured perception even more. Some felt awe. The universe felt alive again, full of depth, full of history beyond human stories. Others felt exposed, as if the walls of our cosmic home had always been thinner than we believed. As if Earth wasn't a center, just a passing reference point. Even within scientific circles, something subtle shifted. Not belief, perspective. Questions once considered philosophical began creeping into serious discussion. What defines a machine? What defines intention? Does purpose require awareness? And most importantly, does discovery always mean understanding? For the first time, observation itself felt unstable. Because normally, when we observe something, it changes how we understand it. This time, it was changing how we understood ourselves, our assumptions, our limits, our place. The object hadn't spoken, hadn't moved towards us, hadn't reacted. Yet it had already altered global conversation without doing anything at all. That realization frightened people more than any imagined threat. Because it meant power didn't require action. Existence was enough. As debates grew louder, one quiet truth emerged beneath them all. Whether 3I/Atlas was artificial or natural no longer mattered as much. The damage, or transformation, was already done. We had allowed ourselves to seriously consider the idea that the universe might contain working systems older than us, not life, not messages, but artifacts. And artifacts don't care who finds them. They don't explain themselves, they just persist. For some, this was awakening, a realization that humanity might not be as unique as it feels. For others, it was grief, the slow loss of a comforting illusion that we are alone in a quiet sky. As the object continued its silent journey outward, public attention surged, then fractured again. Interest spiked, then fatigue followed. The world has short attention, but unease lasts longer. Because even when people stopped talking about 3I/Atlas, they didn't stop thinking about it. Every strange star, every dark object, now carried a question it never carried before. Is this just nature, or something else? That shift in perception was irreversible. We had crossed a psychological boundary, not because the object demanded it, but because we allowed ourselves to imagine beyond safety. And imagination is the most powerful force humanity has. As 3I/Atlas faded slowly from public focus, one question remained unspoken, but shared by many. If the truth turns out to be stranger than comfort allows, are we actually ready to know it? Because once perception breaks, it never fully returns. And whatever this object truly is, it has already done something remarkable. It has forced humanity to look at the sky and feel uncertain again. Not about danger, but about meaning. And that uncertainty is where the next silence begins. It stopped without warning. No countdown. No fading. No final surge. One moment, the pulse was there. Steady, reliable. Almost comforting in its rhythm. And then, nothing. The graph flattened. At first, no one reacted. Silence, in science, is often just delay. A missed data packet. A temporary drop in signal quality. So they waited. Minutes passed, then hours. The flat line didn't move. The brightness stayed constant. The timing markers showed no variation. The rhythm that had defined 3I/Atlas for weeks was gone. Like a heart monitor after a long beep, the first response was denial. Check the clocks. Check the calibration. Restart the pipeline. Engineers ran through every failure scenario they knew. Loose connections. Software bugs. Data corruption. Nothing explained it. Other observatories were contacted immediately. Different instruments, different teams, same result. Silence everywhere. The pulse had stopped. Across the entire planet. That's when the room changed, because noise can vanish by chance. Patterns rarely do. The light curve that once stepped with precision now drifted smoothly, like an ordinary object, like everything else in space, as if nothing unusual had ever happened. And that was the most unsettling part. It didn't glitch, it didn't decay. It normalized, as if the anomaly had been switched off. Some felt relief. Maybe this was the answer. A system under stress had failed. A natural process had ended. Comets burn out. Reactions stop. That's comforting. But comfort didn't last long, because the thermal data didn't collapse. The temperature remained stable. The reflectivity didn't degrade. The object didn't fragment or slow. It didn't look broken. It looked quiet, like a machine that had gone into standby. Someone asked the obvious question. If it failed, why does it still look so healthy? Failure leaves scars. Chaos, entropy. This left none. The silence was clean. Too clean. And then another thought surfaced. One wanted to voice. What if the pulse wasn't failing? What if it was finished? The idea spread slowly, like fog. What if the pulse was never meant to be permanent? What if it was a phase, a mode, something that turned on, did its job, and then stopped? That interpretation changed the silence completely, because now the quiet wasn't absence, it was completion. The data before the silence was reviewed again, every cycle, every timing shift, looking for clues, looking for an endpoint. And when they plotted the full timeline, something chilling appeared. The pulse didn't stop randomly. It stopped at a consistent interval after perihelion, after peak solar exposure, after maximum energy intake, as if perihelion had been the trigger and silence was the result. That timing was impossible to ignore. It suggested sequence, input, processing, shutdown. That's not how natural systems behave. That's how operations conclude. Someone whispered the thought that had been building for weeks. What if it noticed us? No one laughed, because that question wasn't about intelligence. It was about awareness. Awareness doesn't require curiosity or emotion, just detection. And we had been blasting this object with observation, radar, optical tracking, infrared scanning. It had been bathed in attention. What if the pulse wasn't a signal outward, but a process inward? And what if, once that process ended, there was no reason to continue? That idea sent a wave of unease through every discussion. Because it suggested asymmetry, we were watching it, but it wasn't watching us. It was doing something else entirely, and we were just nearby. Some tried to ground the conversation. Let's not anthropomorphize, they said. Machines don't notice, but machines do detect. They register changes. They respond to thresholds. They adjust behavior. And the data showed adjustment. The silence didn't weaken gradually. It stopped decisively, as if a switch had been thrown. The public, already divided, reacted in predictable ways. Skeptics declared victory. See? It was nothing, just noise collapsing under scrutiny. They welcomed the silence, because silence meant safety. Others felt the opposite. They felt watched, not because something was active, but because it wasn't, because something had finished doing whatever it came to do. And we didn't know what that was. Late at night, scientists stared at flat lines on glowing screens. They had never been afraid of silence before. In astronomy, silence is normal. Most of the universe doesn't speak. But this silence was different. It wasn't empty. It was intentional. The object continued moving, outward now, away from the sun, away from us. Still stable, still reflective, still intact, just no longer pulsing. As if the rhythm had been a temporary state, like waking, then sleeping again, or like booting up, then shutting down. That analogy haunted people, because shutdown implies readiness to restart. Not now, not here, but somewhere. So men. As days passed, the silence held. No return of the pulse, no flickers, no anomalies. Just a normal-looking interstellar object, the kind scientists had always expected to see. And that normality felt wrong, because it erased weeks of evidence without explaining it, as if the universe itself had smoothed over a wrinkle. Some researchers archived the data quietly. Others couldn't stop replaying it, trying to understand if the silence was the end or a message in itself, because silence can mean many things: failure, completion, avoidance, or indifference. Indifference was the most unsettling option of all, because it suggests scale. A scale where our attention doesn't matter, where observation doesn't interrupt process, where we are simply irrelevant. As 3IATLAS drifted farther away, public interest faded again. News cycles moved on. But inside the scientific community, the silence echoed, because something had changed. We had witnessed a phenomenon that behaved like a system, then chose not to. And we had no explanation for the choice. That left one final question hanging in the air. Not loud, not dramatic, just heavy. Did it fail? Or did it decide it was done? Because if this silence was intentional, then the most important part of the story didn't happen when we were watching. It happened when we stopped understanding. And that silence may be the loudest thing 3I/Atlas ever said. At some point, the questions stopped being about the object. That change was subtle, quiet, almost invisible. But once it happened, there was no going back. Because even if every anomaly surrounding 3I/Atlas were explained tomorrow, every pulse reduced to physics, every thermal shift folded neatly into equations, something had already broken, not in space, in us. For centuries, humanity has looked at the sky with confidence, not certainty, but comfort. We believed the universe followed rules we were slowly uncovering, that surprises existed, but only within boundaries. 3I/Atlas didn't explode those boundaries. It stretched them. And stretching is more dangerous than breaking. Because when something breaks, you rebuild it. When something stretches, you realize how thin it always was. After the silence, the data reviews continued. Carefully, methodically. Scientists did what they always do. They tried to put the universe back together. Alternative models were proposed. New simulations ran overnight. Papers softened their language. Unusual, but explainable. Rare, but natural. Complex, not artificial. All reasonable, all possible. And maybe all correct. But correctness wasn't the point anymore, because the experience had already changed the lens. The way people read the sky was different now. Before 3I/Atlas, anomalies were errors to be removed, noise to be filtered out. After it, anomalies felt like questions, and questions linger. Astronomy has always been about distance, about scale, about things so far away they feel abstract, but this felt close, not physically, psychologically, because the object didn't arrive with drama. It didn't threaten. It simply behaved in ways that forced us to confront a deeper truth, that our models are not the universe. They are guesses. Good guesses, powerful guesses, but still guesses. 3I/Atlas didn't prove intelligence. It didn't prove design. What it proved was uncertainty. And uncertainty is uncomfortable for a species that has built its identity on knowing. In the weeks after the silence, conversations shifted. Less excitement, more reflection. People asked quieter questions. Not what was it, but why did this affect us so deeply? Because nothing had really happened. No contact, no message, no danger. And yet, the meaning of discovery had changed. Before, discovery meant answers. Now, it meant consequences. Because discovering something doesn't just add knowledge. It rearranges belief. The idea that something could pass through our solar system, behave like a system, and leave without explanation. That idea stayed, even if proven wrong. Especially if proven wrong. Because once you imagine a possibility seriously, you can't fully erase it. Scientists felt this shift too. They didn't say it publicly, but in private, many admitted the same thing. They trusted their instruments more and their assumptions less. They realized how easily expectation shapes interpretation. How often normal is just what we're used to seeing. 3I/Atlas had forced them to slow down, to listen longer, to sit with ambiguity instead of rushing to closure. That alone was transformative. For the public, the shift was more emotional. People began to talk about space differently. less as a backdrop, more as a place of history. Not just stars and rocks, but events, processes, possibilities that don't center around us. That realization was humbling, and humility is rare in human progress. The most unsettling part was this: even if 3I/Atlas turns out to be natural in every way, it still behaved as if it wasn't, and as if is powerful. Because perception shapes response, and response shapes future science. Funding discussions changed tone. Search strategies were quietly reconsidered. What if we've been looking for the wrong things? What if intelligence doesn't shout, but endures? What if technology doesn't announce itself, but blends in until we're ready to notice? These questions didn't require 3I/Atlas to be artificial. They only required us to imagine that it could be. That imagination alone altered the trajectory of thought. There was also grief. A subtle one. The grief of losing a simpler universe. One where everything unfamiliar eventually became familiar. Where mystery always resolved. 3I/Atlas suggested a different future. One where some things remain unresolved, not because we failed, but because resolution isn't guaranteed. That idea unsettled people more than any threat ever could, because it means knowledge has limits, not temporary limits, permanent ones. As the object faded farther into the dark, it left behind no trace, no debris, no signal, just archived data and unanswered questions. But the impact wasn't in the data. It was in the pause people felt when they looked up at the night sky. A moment longer than before, a thought that lingered. What else is out there that we don't know how to recognize yet? This wasn't fear. It was awareness, an awakening of scale. The realization that discovery doesn't always clarify the universe. Sometimes it complicates it. And that complication doesn't go away. It becomes part of how we think, part of how we teach, part of how we explore. 3I/Atlas may never return, may never pulse again. It may fade into footnotes and academic debates, but its real legacy is already secure. It reminded us that certainty is fragile, that patterns matter, and that meaning isn't always found in answers. Sometimes it's found in questions that refuse to disappear. The object didn't need to be special. We made it special by paying attention, by allowing doubt, by admitting that the universe may be stranger than our confidence allows. And that admission marks a shift, a quiet one, but irreversible. Because once you accept that the sky might contain things that don't fit clean categories, you never look at it the same way again. As 3I/Atlas continued its silent journey outward, one final realization settled in. Discovery didn't just reveal something new about space. It revealed something new about us. Our hunger to understand, our fear of not knowing, our need for meaning even when meaning isn't offered. And maybe that's the true impact of this object. Not that it changed the universe, but that it changed the way we stand beneath it. And as we prepare to close this chapter, one last question remains. Not about 3I/Atlas, but about ourselves. If discovery can reshape belief without providing answers, then what happens when the next anomaly appears? Will we rush to explain it away, or will we listen longer this time? Because the sky hasn't changed, but we have, and that may be the most important signal of all. In the end, there was no ending, No final reveal. No hidden message decoded at the last second. No answer waiting patiently in the data. 3I/Atlas simply kept moving. Day by day, it grew dimmer, farther, colder. Its path carried it away from the sun, away from our instruments, away from certainty. Back into the dark it came from. The telescopes followed as long as they could, longer than usual, longer than budget or routine would normally allow, because no one wanted to be the one who stopped looking. The last usable data arrived quietly. A final set of numbers, a final position fix. No pulse, no anomaly, just motion. And then, nothing. The object slipped beyond the limits of meaningful observation. Too faint, too distant, gone, not destroyed, not resolved, just gone. In astronomy, this happens all the time. Objects pass through. They fade, but this one left a weight behind, because unresolved questions don't disappear when the signal does. They linger. They follow you home. Scientists archived the files, labeled them carefully, stored them for future review. That's what science does when it reaches the edge. But the unease didn't go into storage. It stayed, because somewhere between the first detection and the final silence, something subtle had occurred. We stopped treating the object as the subject and started treating ourselves as part of the equation. At the beginning, the question was simple: what is it? By the end, the question had shifted. What does it mean that we noticed it? 3I/Atlas never changed course, never slowed, never reacted in any visible way to our attention. And that fact mattered, because if it was natural, then it was a reminder of how little we still understand. And if it was artificial, then it was a reminder of how small we might be. Either way, the conclusion felt the same. We were not the center of this story. The origin of 3I/Atlas remained unknown. No star system pointed cleanly backward. No clear birthplace revealed itself. Its past was smeared across time and space, like a fingerprint rubbed away by distance. That alone was unsettling. Because origin is how we make sense of things. We understand by tracing backward, by connecting cause to effect. This object denied us that comfort. It arrived without a beginning we could name, and left without an ending we could define. Some tried to move on. This is science, they said. Not every question has an answer, and that's true. But not every unanswered question feels like this, because this one didn't feel incomplete. It felt deliberate, not in the sense of intention, but in the sense of indifference. As if the universe had briefly shown us something, then looked away. The more time passed, the more the story softened in public memory. New discoveries took its place. New headlines replaced old ones. That's how attention works. But in quiet moments the thought returned. If an object like this could pass through our solar system once, it could happen again, and next time we might not recognize it at all. Or worse, we might, and still not understand it. Somewhere in the dark between stars, 3I/Atlas continues its journey, still intact, still silent, still carrying its unanswered origin with it. It doesn't broadcast, it doesn't glow, it doesn't care that a small species once pointed instruments at it and wondered. And that might be the most important lesson of all. We often imagine discovery as a conversation. We ask, the universe answers. But sometimes discovery is one-sided. Sometimes we observe, and nothing observes us back. Or so it seems, because there is one final question no data can resolve. Were we watching a mystery unfold, or were we briefly inside something else's field of view? Not seen, not targeted, just present, like ants beneath a passing shadow. That idea doesn't require intelligence. It doesn't require intent. It only requires scale. A scale where systems move through star systems, the way comets move through ours. A scale where survival matters more than communication. A scale where existence itself is the function. If that scale exists, then the universe is filled not with voices, but with remnants, with machines, with artifacts, with processes older than memory, passing through, working, ending their cycles far from where they began. 3IATLAS may have been one of them, or it may have been nothing more than a strange arrangement of matter. Both possibilities remain open, and that openness is the final truth. We did not solve the mystery, we encountered it, and encounter is enough to change perspective. As humanity looks forward to deeper space, to new instruments, to sharper eyes, the shadow of this object remains, not as fear, but as humility. A reminder that the universe does not owe us clarity, that observation does not guarantee understanding, and that some questions are not meant to be answered quickly, or at all. 3IATLAS came and went without explanation, but it left behind something more enduring than data. It left behind doubt. And doubt, when held carefully, becomes curiosity. Curiosity becomes caution. And caution reshapes how we explore. The next time an anomaly appears, the next time a light curve looks wrong, the next time silence follows a pattern, we will remember this moment. We will hesitate. We will look longer, because we now know that the sky can hold things that do not announce themselves, things that pass through our story without entering it, and perhaps that is the quiet truth this object carried with it, that the universe is not empty, not loud, but full of movement beyond our attention, full of systems that don't need us to exist. 3I/Atlas drifts onward now, unresolved, its origin unknown, its purpose unconfirmed, and maybe that is exactly how it was meant to be. Because some mysteries don't arrive to be solved, they arrive to remind us that observation is not ownership, that knowledge is not control, and that sometimes the most profound discovery is realizing we are not just watching the universe, we are inside it. And every so often, something passes through and watches nothing at all, leaving us behind, staring into the dark, wondering who or what will pass next.